Let's get started. So the topic for the day is data science and machine learning using Python. It's presented by Mationalytics. What is data science? What is machine learning? Uh, because people who hear such words are generally confused. What is this all about? I've heard database, then there was this data mining, then data science, data analytics, machine learning, artificial intelligence. So there is so many jargons around. First of all, we need to get our definitions right. This is one of the classic Venn diagrams which is used to explain what is machine learning and what is data science. Let's go here. So mathematics and statistics, as we know, has been existing for several centuries. The people have been proposing different mathematical algorithms and statistics algorithms. This has been there for a while, and maybe for the past 40 to 50 years, computing and software has also been getting established over time. So it started several decades ago, and the level of computing capacity, cloud environment, high computing environment, graphical process units, so graphics cards, and different programming languages. So this vertical has also been there for a while, and even without mathematics and statistics, people have been doing business. So whoever is having a retail store was continuing to sell things for several decades. People who have been lending money or giving credit cards have also been doing this for a while. So the domain expertise has always been there. People have been doing business independent of anything, either mathematics, statistics, or computing. So they are in a way some independent, larger uh, growths which has happened in the past. And this merger of mathematics, statistics with domain happened again several decades ago. People with a strong mathematics and statistics background and also know the domains, let's say manufacturing and construction, or supply chain optimization. So people who know the domain as well as the mathematics were able to combine these two and do traditional research, mostly from academia, trying to publish papers or solve some problems with some academic algorithms. So this combination of mathematics, statistics, and domain knowledge has been there for a while. Even this combination has been existing for a bit now, especially after the era of internet. People who know the domain well and also know computing software skills, they do, let's say, digital marketing, e-commerce, uh, or even people who do hacking. So this combination has also been existing for a while. People who use computing and software skills and apply for certain domains. In this combination, trying to convert the existing mathematics and statistics algorithms into a usable software piece, that is called machine learning. Mathematics and statistics which is made usable as a software. So this is machine learning. Again, have been there for close to 30-40 years now. There have been people who have been doing machine learning for at least 30 to 40 years. And this combination of computing softwares, mathematics, statistics, and applying to solve business problems. So all these combinations put together is called data science. So you have mathematics and computing statistics put together as machine learning, and you apply machine learning to solve business problems. So apply machine learning to solve business problem, and that is called data science. So a person who claims who has done machine learning are ones who can build statistical models, do some mathematical models. They are the machine learning experts, and those who can apply that also for a business problem can be called as a data scientist. So this is the classic definition of machine learning and data science. And data science has been getting popular only in the last decade. Maybe after around 2005 it started becoming popular. There were articles on data analytics, data science, and it was slowly gaining traction. And the past 3 to 4 years the growth has been phenomenal. And there are reasons for this to happen, and that's what we want to get started with. We wanted to see what is data science. Why data science? That's the most important thing. We have so much data. We are generating uh, every day 2.5 quintillion bytes of data. That's a humongous amount of data, and 90 percentage of data which is there in the world today has been created in the last 2 years itself. So which means we are generating a lot of data, which means there is a need for someone to make insights out of the data. So much of data is being generated. Can I make a use of it and make business out of it? That is the reason for using data science. And people have already started using it, especially retail, manufacturing, even in finance, it across several domains. And there was a recent report which says data analytics could increase annual GDP of retail and manufacturing up by $325 billion by 2020. That's a big push. So a domain like retail and manufacturing can increase its GDP by 325 billion. That's a big thing. Then anyone in that particular domain will jump on data science because they are going to make money out of this. See how Amazon has been able to make money uh, by using data. See how Google has been able to make money using data. So people will jump in when there is a pile of cash sitting. And IDC forecasts that big data itself as a technology and services sector is to grow at a 23 percentage compounded annual growth rate. No other industry is growing with such a rapid rate, not cloud, not software development, uh, etc. And it is expected to reach around that itself will become a $50 billion industry by 2019. Currently, uh, uh, it's a $2 billion industry even in India itself, and globally it is around a $10 billion industry, and it is going to become a 48.6 billion. That's the prediction by IDC, very authentic reports. So I have a question from someone saying, what about deep learning? What is incorporated with like math statistics? So question is on deep learning. So there is, while machine learning and data science is being hyped, there are also a lot of hype about deep learning. Deep learning is a branch of machine learning. So what is machine learning? We teach a machine, like we have been taught in the past, what is ABCD, what is one, what is two, what is red, what is blue, what is a triangle, what is a rectangle, what is a square. So we have been taught, we learned, and at some point in time we learned many things and we started taking decisions. So that is how we learned. And if we have to teach a machine like a computer, then it is called machine learning. Now comes the question, how do you teach? If you teach statistically, that is one group of uh, one set of learning algorithms. And if you teach it like a human being, that's called neural network. And that is another set of algorithms that is called deep learning. Okay, and there were certain incidents which pushed this. When we look into data science, we should also know the history behind why this is being popular and what triggered this growth. One of the events was Google has Google Trends, and Google was able to uh, predict flu outbreak even before Center of Disease Control was able to do. There was a flu outbreak in late 2000s, 2008, 2009 timeframes, and Google was able to tell, okay, these are the states and these are the regions which have a high probability for a flu attack. And they did it even before Center of Disease Control was able to do. Center of Disease Control is the department which takes care of all disease prevention, mitigation, etc. And they generally know which regions are prone to attack. But Google was able to precisely predict using historical data and say these are the regions which are prone to get attacked by flu, even before Center of Disease Control was able to do. This created a lot of hype in US, and also elections, be it Obama's win or Trump's win. They used data science exhaustively, and after their victory, there were so many articles which got published how they are using data science to win their elections. If you know DJ Patil, I think most of you would know he is the most popular person in the data science world because he was the first US chief data scientist in White House appointed by Obama. And Obama started valuing data science so much, and he created a position called chief data scientist in White House. And now almost every organization has a chief data science or a chief data officer who heads the data analytics practice in any organization. So Obama used data science exhaustively, and even Trump, he used data science exhaustively throughout US. And in Arizona, it was an Indian who helped Trump capture Arizona, which is the opponent's foothold. And there was so much articles around how Avinash helped Donald Trump win Arizona. So two messages: one, data science being exhaustively used; two, there is a lot of Indian connection. So be it DJ Patil, be it Avinash, be it any top data scientist around the globe, you will see a majority being Indians, because this deadly combination of computing software, mathematics, statistics, and blend it with domain, this deadly combination is not, it's a rare mix. And Indians, or in general Asians, are believed to be strong in mathematics, statistics, and we are also known for our software and computing skills. And these two blended and used for with domain expertise. So this deadly combination has given a lot of advantage to Indians. That's why you will hit with a lot of Indian names whenever it comes to data analytics and data science. This is not just in US, Europe, across the globe, you'll see a lot of Indian presence in data science. And another being Google. Google monetized data so much. As we know, when we do a Google search, we will see a lot of sponsored ads coming in, and Google is making most of its revenue through these sponsored ads. The moment you do a search, let's say someone searched for towel bars, and they would have probably signed into their Gmail account when they are doing the search, and Google will immediately collect the data saying, hey, someone, let's say Karthik, who is aged 35, based out of this location in India, is searching out for towel bars, and historically he has searched for Reebok shoes, Raymond glass, Motorola Moto X phone. So they will, it knows their entire history, and it packages this entire data and pushes it to what is called as ad tech companies. So it will push this data in fraction of second. Moment you do a search, it will push all this information about you to ad tech companies, and these ad tech companies will be managing the revenues of different companies, and they will decide, okay, should I post an ad for Karthik? If so, what advertisement should I push, and for how much price should I bid this space? What Google will do is, hey, I have three space to advertise, and whoever is the top three bidders will get this space. Now I have to decide, should I bid for 10 cents, or should I bid for 50 cents, or should I bid for $1? This decision has to be taken by ad tech companies. So Google makes money using data, and ad tech companies also would have historically known, they have their models trained saying people with this kind of characteristics have a high probability to buy this kind of a product, and they will position the ad accordingly. Everything using data, and all these happens in fraction of seconds. You don't really know because you just search, and your search results comes along with the sponsored ads. But so much of work happens in that fraction of second. Google prepares the data about you, pushes it to ad tech companies. Ad tech companies run models and identify the probability of you hitting the particular advertisement, and decide the price at which it has to be bid, and shows the advertisement. All these happens in fraction of seconds, an exhaustive usage of data science and computing skills. All these ad tech companies have big servers doing this bidding using several statistical models. And Google makes approximately $50 billion per year from sponsored ads. which corresponds to 97% of the company's revenue. So all their Gmail, Google Drive, whatever they have, which they are giving it to us free of cost, they are making all the money out of the sponsored ads, which corresponds to 97% of their revenue. And it's an auction, pure competition for marketers trying to win access to consumers. And of course, there can't be any human being who can decide in a fraction of a second. So this is competition of models, several ad tech companies competing for the space, and they decide based on likelihood for someone to respond to an ad. An out and out usage of data science. So where is data science being used? Let's look at it by functions. Marketing. A lot of organizations do churn analysis. Most of the organizations who are doing B2C, for example, telecom organizations like Comcast, AT&T, T-Mobile, in case of India, let's say Airtel, Vodafone, whoever does a B2C, they always wanted to do churn analysis. They are saying, what is the probability of my customers to leave me? So they are churners and they wanted to predict it even before they leave based on historical data of people who historically left my network and went to a different network. They look at their transactions. How many times did they call center? Did they have billing issues? Uh, 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 what is the kind of data usage they have? Do we have enough plans with that? So a lot of historical churners data are used for teaching a machine, and then a machine does a prediction of out of your existing customer base. It gives a probability for each and every customer, saying what is the probability for them to leave you. Then I can pick the top 10 percentage high probable churners and then try giving a promotion, doing a discount, or calling them, asking them what is their feedback, are things okay. That's on churn analysis. Customer segmentation. This is again exhaustive usage of data science. I use Uber, my wife uses Uber. I get a promotion, but my wife doesn't get a promotion. I was always surprised. Why do these guys even do this? But I realized when I started moving to doing more and more of data science, they have these customer segments. They statistically divide their customer base into different segments, call them one segment as okay, elite, frequent travelers, ready to pay, others being occasional travelers, very cost sensitive. They could switch between Ola, Uber, or taking an auto, bus, train. So they have segmented their customers into different buckets, and they send customized promotions to different segments. And it is all done using data science algorithm. There are a lot of clustering algorithms in data science, which is used for segmentation. Again, product segmentation, market mix models. Let's say a company like Apple. Apple wants to do advertisement, and they could do advertisement through different channels. They could have some print advertisements going through different channels. They could do digital advertisements in Facebook, Twitter. They could post it in different web pages. They could do it in radio. They could do it in television. And they would always want to like to measure, okay, which channel gives me the maximum uh, turnaround of customers. So if I spend more in digital media, I get more, and in print media, there isn't much. I'll give an example from Mationalytics standpoint itself. So all our trainings, our sessions, we try to spread the message through different channels, through WhatsApp groups, Twitter, Facebook, websites of different US states or European regions, and also print media. Try to stick some flyers in different regions, and we keep measuring which channel gives us enough trainees and how many of them are converting as trainees to our organization. Even we do. It's a market mix model. We always try to see which channel gives me a better turnaround of customers. This is again a popular data science technique. Whom should I target for discount? How do I optimize my AdWords? And sales teams. Sales team gets a lot of leads, so there will be 100 people who will be asking for quotation. But whom should I give priority and whom should I give not? Whom should I not give a priority? So I can have a probability done for each lead, saying okay, this lead has a high probability to get converted as a business, and probably other leads don't. and I will prioritize leads which are used or which could convert to a business for me. Demand forecasting in logistics. A manufacturing company would like to do this. Let's take an Indian example, Maruti. Alto is the highest selling car in India, and they would like to know in the next 4 quarters what is going to be the demand for Alto, because they have to scale up their manufacturing, they have to scale up the ancillary units, they have to scale up their warehouses, they have to scale up their sales muscles. So for this, demand forecasting is important. So historically, by looking at historical data, how is future looking like? Can I forecast what is going to be the demand for Alto for next 4 quarters? If I do and give it to Maruti, they will trust that number and they will prepare their entire pipeline of logistics, everything put together. Banking, again, credit risk. If someone applies for a credit card or a loan, is he a good credit or a bad credit? Most of the organizations have started taking data driven decisions for this. There are only handful of companies who don't use data science but just go by just a TransUnion CIBIL score in India, or a different score from TransUnion in US. But most of the big credit or banking companies have started using data science exhaustively for credit risk classification, classifying a person who has applied as a good credit or a bad credit. Again, fraud detection, very popular in US. So people just steal credit cards and swipe it. How do we classify between a good transaction and a fraudulent transaction? This is a big market in banking and financial sector. A lot of data science goes in fraud detection. Customer support, again, some speaker recognition, call center message optimization. Even HR have used a lot of data science. Can I know which of my employees are going to churn out of me and join a different organization? What trainings can be recommended? How do I do talent management? Assurance, hospitality, life science. Let me not spend more time on this. So what are the popular data science and machine learning concepts? Again, I will not get into too much theory. I'll give a quick glimpse. Social media analytics. This is a big area where data science is being used, because a lot of people post any organization would like to have consumer insights. Like, what are my consumers speaking? I know my sales, but what is going on in the consumer mind? And earlier it was very hard to do, but now that all Twitter, Facebook, blogs, uh, organizations are able to get consumer insights by mining social media. So analysis of Twitter, Facebook, blogs, web scraping, all these is getting very popular. So social media analytics is it's a topic by itself. Doing sentiment analytics. If I'm going to launch, if iPhone 8 is launched, what's the sentiment of my consumers? What are people speaking about it? Are there any feature issues? Are there issues in services? So people do a lot of social media analytics. Web scraping, as I told, people post a lot of things in blog. There are websites which keeps updating things like Sensex in India, any stock market, they keep publishing things in their website, and there are organizations who scrape these websites and then track the trends of different stock markets. Web scraping. Regression, very popular, many of you would have heard. How do we establish relationship between variables and use it for predictive analytics? Let's take a simple example. If I know weight and height of some 100 people, so every person is a point here, weight in x-axis and height in y-axis. If I know the general relationship between weight and height, can I fit a model? So this line is a model, and it's an output of a regression model. It is trained using what is called as a partial least square algorithm. Having built this model, then for person with any height, I can predict what is going to be the weight, or if I know the weight, I can predict the height. I can build a relationship between height and weight, build a regression model, and predict for any new combination. Another practical application, uh, my advertisement spent in x-axis and my sales in y-axis. For different occasions, I have spent so much on advertisement and so much is the sales generated. If I know the historical relationship, I can fit a model. And in future, if I'm going to say, okay, I'm going to spend $1 million next year for my advertisement spend, how much sales can I expect out of it? From this model, I can do a prediction saying, okay, If you're going to spend $1 million, you are going to expect so many millions of dollars in return through sales with a range of plus or minus so much deviation. So you can do such predictions using regression analysis. Classification. So as I told, we know how to differentiate between apples and oranges because we have been learnt in the past, we have been taught in the past, and we have learnt. Similarly, can I teach a machine not necessarily between apples and oranges, but between a good credit risk and a bad credit risk, between uh, uh, between a spam email versus a good email? So Google is able to classify your emails into different buckets automatically: promotions, social media, spam, junk, primary, and this is a classification task. How do I classify any data into different buckets? So this is classification. And clustering, as I told you, Uber example, how do I segment my customer base into different groups so that I can do different promotions for different customer groups? It is also used by a lot of policy makers. Let's say if Narendra Modi would like to launch certain schemes, he has like 10 schemes in mind and want to have some target districts in India to launch those schemes, then a data scientist can cluster the Indian districts into different groups, saying, okay, this district is a high earning manufacturing district with a lot of young people. This district, pretty much a retiring place, a lot of old people with this kind of challenges. So the entire Indian districts can be segmented into different groups based on education, income, healthcare, what kind of professions they do, etc. And we could do a clustering. And Modi could say, okay, launch this particular scheme here, this scheme here, this scheme here, this here, and this here. Or if Uber wants to do, Uber can say, okay, give this promo, Elite 50 here, Summer 40 here, Rainy 30 promotion here. So they can do customized discounting and promotions for different. Okay, I get a chat window from of someone who has joined from London, who shares his experience saying, right from big hotel to small restaurants, he says they have also been using data analytics for a while. Because I gave an example of hotel, I was surprised. He shares his experience from London, says that hotel industry has been using data analysis for several years now. So thanks for sharing, Prasanna, in the private chat. Okay, another being dimensionality reduction. I will not touch on this. It's fairly involved math. There is a technique called principal component analysis to do project data from a high dimensional space to a low dimensional space. There are so many openings on data science. As you see, this is job trends from indeed.com. Uh, Search terms being big data, statistical analysis, data mining, data analytics using R. Similarly, big data, statistical analysis using Python. You could see the overall growth for R as well as Python. Significant growth in the past few years. No other skills have seen such a significant growth of job postings, and data analytics, data science is seeing this, especially Python as well as R. As you could see, blue line is Python, having a mild edge over R, because Python is more a production ready tool than R. So it has a mild edge, and people from an IT background generally prefer using Python as a mild edge over R. That's from Indeed. And this is from Google Trends, what you see in the right, very recently pulled data. Blue line being data scientist R, the orange line being SAS, and green line being Python. Again, R, Python going hand in hand. Python having a small edge over R, and SAS, of course, growing because data science is growing, but it is not growing as much as R and Python because it's a licensed proprietary tool. Companies are reluctant to pay for the license. A lot of people migrating from SAS to R and Python. So R, Python having a strong growth. No other skill set has seen such a growth in a short span of time. And what you see here is analytics and data science job growth in LinkedIn. So job growth is phenomenal, and of course most of you who have joined this session know that there are so many job openings for data science. It's one of the highly paid skills across the globe, be it India, be it US, or anywhere. In India, I've seen people earning at least twice what any other person of same experience with a different skill set could earn. And it's the same in US as well. There is a clear skill arbitrage when someone has data science skills. And since there is a lot of demand, organizations are ready to pay, and they know it is a very niche skill. And this talent gap is going to be there for a while. So whoever jumps into data science at this point in time, they are going to get a clear mileage out of it. So that's how the job trends are looking like. And there are a lot of reports as well, which predicts that things are also looking green. So data science is being touted as the hottest career option in 21st century. And McKinsey predicts that there will be 140,000 to 180,000 data scientist job openings by 2018 in US alone. It's not even global. In US alone, it is expected to have 140 to 180,000 data science openings. There are significant openings in Europe. We have some participants in from London as well here who have joined, and there is a big talent pool gap there for data scientists as well. And of course, in India as well, everywhere there is a big gap. And recently, NASSCOM, as you know, it's an authority in India, and they expect data science, data analytics to have an eightfold growth and become a $16 billion industry by 2025 from what it is being a $2 billion industry. It's getting big, and it is going to get much bigger, and it is going to stay strong at least for a decade, at least till 2025, 2030. This is going to be the fastest growing skill set, which is going to be of high demand in the industry. Why Python? Uh, so a lot of you had a question on why Python. So there was a survey conducted by Codeval, and Python was flagged the most popular programming language. So this has nothing to do with data analytics, data science. General programming languages, what are the most popular languages? You see C++, Java, of course, very strong. PHP, Ruby, JavaScript, C, Scala, Perl, uh, Pickle, some small players here and there. R, if you see, the base is quite low because it is exclusively used only for data analytics, data science. R is not used for any other purpose. But Python is an ocean. Python can be used for application development. You can use it for automated testing. You can use it for some data analytics. You could use it for some report automation. You can use it for even UI development. So the usage of Python is quite vast compared to any other programming language, and that's why it is getting more and more traction. Because if someone learns Python, they know that even if I am unable to get into data analytics, data science, which is clearly an elite, elevated kind of a skill set, I can at least do something else. I can do Python based software development and slowly move towards a data science. So people get a lot of room to move around and so many opportunities out there. So that is also a reason sometimes people prefer Python over R. While R and Python from a data science standpoint, both of them are comparable and growing strong. Some prefer Python over R because Python's usage is quite wide. People use it for different applications. So if someone learns Python, they feel they could use it in something or the other, gain some experience, and then get into data science. If not today, at least tomorrow. Free and open source. That's the biggest uh, reason for people moving towards Python, and R also for that matter, because they are free and open source. SAS, Minitab, the so-called historically popular data analytics tools were highly priced, and larger organizations want to cut their cost, and they wanted to migrate to languages which are more powerful than uh, which they are more powerful than SAS or any other proprietary tools, and it is also free of cost, and it's also open source. I can get access to every nuts and bolts of the code, which I can do in Python as well as also in R for that matter. Python, I can use it like a Swiss knife because Python is a general purpose programming language. So I can, using Python, I can become a general purpose programmer, and I can also use data science. There are a lot of packages like NumPy, Pandas, Matplotlib, scikit, natural language processing toolkit. So a lot of packages available. So I can use it like a Swiss knife. If needed, I will use it for application development. If needed, I can also use it as a data science tool. That kind of an advantage only Python has. No other language has usage like a Swiss knife. And nice IDEs, even though it is free open source, it's not like you have to type it in a black screen. You have to always use a VA editor to program. It is hard to do, etc. It is very easy. It has an IDE called Spark, PyCharm. You can also program in Eclipse. You can program in Notepad++. Almost all popular integrated development environments, IDE stands for Integrated Development Environment. Almost all popular IDEs support Python, so you can easily write programs. So much of support. If you do a tab, you will get help. So very interactive IDEs available for Python. Very simple to program. It is not a complicated like people are comparing with Java, C Sharp. If you have to write a logic, it takes a lot of programming and you have to sweat out to do it in C Sharp or Java, but you can do it in one line in Python. Very simple to program, but at the same time scalable to productionize. You can put your piece of program on a big data ecosystem like a Hadoop or Spark, or put it on a TensorFlow, which is used for neural networking, or you can put it on a cloud-based environment. Or if you want to have a web front end, you can interface it easily with JavaScript. So this level of productionizability again is present only with Python. Simple to program and very scalable to productionize. As I told, seamless integration with big data ecosystem, be it Hadoop, Spark, or a web development like JavaScript. The interface is quite easy to do. That's the reason again people look for Python. Okay, on timelines, Python was announced in 1990, so that's when it became public, and version 1 was released in 1994. Since then there has been several versions, and Python 2.7 was launched in 2009, and 2.7 of course had several variants, 2.7.1, 2.7.2, etc. And 2017 we have 3.6.2. While this is the latest version of Python, this is the version which is the most stable version. So Python 2.7 is the widely used version of Python among the Python community as well as the larger data analytics, data science community. If someone who joins our training, what do they get to learn? They get to learn two streams. One is Python for data processing, where they get to know what are the data types in Python. That's the fundamentals of data, any programming language. What is integer? How is float in Python? List, dictionary, and we'll get into packages like NumPy, Pandas. They all have their own data types. Understanding the data types and slicing and dicing of data. This is the first thing someone has to do. Even before getting into any building of sophistication models, someone should be able to slice and dice the data and look at data from different sides. And that is the most time consuming piece of work as well. In practice, I have seen that any machine learning solution which we do, 80% of the work goes in slicing and dicing of data and preparing the data, and only 20% of effort goes in doing machine learning on the data. Because machine learning, there are standardized packages, but the slicing and dicing of data has to be customized for that particular application. So how do you do slicing and dicing of data with Python? Very powerful. Python has a lot of powerful functions for doing. Control instructions one has to do, because if conditions, for loop, while loop, any programming language, whoever learned, they should know how to do control instructions in a programming language. And then we get into optimized data processing, saying, hey, you know what? You can write for loops and do certain actions, but you don't need to do that. And it is not the most computational efficient way of doing, but you can use some optimized functions in Python and do some data processing. We will do, these are some advanced data processing concepts using Python. And how do I read external files, do some processing? How do I merge? If I have 1,000 files, how do I merge them, do some insights, and then write it back as another file or write it to a database? How do I do? That's done in file processing. And finally, visualization. How do I visualize data? How do I look at distribution of data using histograms, box plots, and line plots, scatter plots, bar plots? How do I do all those things? That's done in the visualization topic. That's track one. And once someone has done it, they can go towards data science machine learning, because this is the prerequisite to do data science. And we cover the most popular data science techniques. Regression, we cover all linear regression, non-linear regression, multiple linear regression, second order, third order, the entire flavors of regression. Clustering, we do k-means clustering, which is the most popular clustering algorithm. Classification, k nearest neighbor, naive Bayes classification, several algorithms, both their theoretical understanding from an intuition standpoint, how do you interpret the models are covered. Dimensionality reduction, principal component analysis is used. Web scraping, we do how do you scrape from a website, extract tables from different websites, and then do insights out of it. We'll do that. And social media analytics, can I live feed of data from Twitter, doing sentiment analysis? That's covered in social media analytics. This is the outline. So Spider, it's an IDE for Python, very popular. You see as console here, which can be used like a calculator. 2 plus 3 is 5, you see here. Or you can write some simple logic. Let's say A is equal to 2, B is equal to 3, D is equal to A star B, print D. So simple logics you can write here in console. Or if you want to write develop a script, you can actually do it here. Let's say A is equal to 3, B is equal to 4, D is equal to A star B, print D. And for you to run this, there are several options. One of the options is selecting the code and hitting run, or doing a control enter. So control, this is command, control key plus enter to execute selected. So I run this and it runs in console and prints the outcome. So let's see how to write the simple logic in Python. So I have to write a function, primary, I have to write a function which will detect whether a number is prime or not. So a number is prime if it is not divisible by any number other than 1 and the number itself. So that's a prime number. And generally people try to implement this using a remainder operation or a modulo operation. For instance, so 3 is a prime number because 3 modulo 2. This is a remainder operation. If I run this, it is 1. So which means it is not divisible. You are getting a remainder. So this 3 is prime. Is 5 a prime number? 5 modulo 2. Remainder is 1. So it is getting divided. 5 modulo 3. There is a remainder 3. 5 modulo 4. Again there is a remainder, which means it's not getting divisible. There is always a remainder, so 5 is prime. So I'm starting from 2 and checked all the way till 4 and made sure it is not getting divided. Is 117 a prime number? Numbers you can't do it manually. You can't keep trying all the way from 2 till 116. Okay, so first of all you have to write a function. To create a function in Python, def is a command to create a function, and I'm creating a function called is prime, to which I will pass an input. And within this function what I'm doing is for a loop which starts from 2 and goes till the input number, and I'm doing if the input number modulo I is equal to 0, if it gets divided, then I will say print not a prime number, and I will also break out of the loop, like how you actually broke out here. 117 you tried with 2, it was not getting divided, it was divisible by 3, and you said okay, I am not going to search anymore, it is not a prime, and I conclude. So like the same way I get an input here and I start from 2, go till the number before that. So this command will actually create a sequence of numbers starting from 2 till a number before your input number, and in the loop I am testing whether the number divided by your looping variable I, whether it is 0 or not. Whenever it hits a 0, it says it's print not a prime number. Okay, so if the loop goes throughout and it is not getting divided at any point in time, then I can do print is a prime number. So I will not do that for now. So I can run this. This is a function, and let me call this function is prime of 3. So not a prime is not printed, which means it's prime. 4, not a prime number. 5, prime. 6, not a prime number. Now let's look at 117, not a prime number. 119, it's also not a prime number. Oh man, okay, so 119 is not a prime number. So where is it? Where did it got divided? So print not a prime number, print divisible by, okay, so Garima says it's 7, divisible by I. Let me also print that. Let me just print I. Divisible by 7. So I'm also printing what number it is being divisible by. What we have done, let's look at the syntax. Definition is creating a function. You are creating a function called is prime, to which you are passing an input, and inside that you are writing a for loop for I in this range. So let's say input is 119. So this range command will generate sequence of numbers starting from 2 till 118. So I'm testing whether the number is getting divisible by that I variable, and whenever it is getting divided, I will say it's not a prime number. I will print what with what it is getting divided, and I will break out of the loop.